Hello, my name is Mr. Whiteman and I'll be going through some GCSE basic mole calculations. A pair is 2 of something, a dozen is 12 of something, a mole is pretty big. That is 6 times 10 to the 23, or you want to be more exact, we can go on for quite a while. A mole is the amount of substance. The unit for this is MOL. Being slightly lazy, we just drop the E off the mole, be MOL. Sometimes we may use the letter N to symbolise an amount in chemistry, but that's not a unit. So in equations you might see something like moles equals mass divided by mR. The number of particles in 1 mole is 6.022 times 10 to the 23, and you're usually presented this in GCSE exam questions if you need to use it. As a fun fact, if you received a mole of pennies on the day you were born and spent £1 million a second until you died at 100, you'd still have over 99.99% of your money in the bank. If you had a mole of basketballs, you could create a new planet the size of Earth. If you had a mole of donuts, they would cover the entire Earth in a donut layer 5 miles deep. A mole of marshmallows on Earth would be 12 miles high, and if everyone that's bound at that point 5 billion people ate 1 marshmallow per second, apparently it would take about 40 million years, and that's without any toilet breaks. That's quite a long time. So, getting straight to it, the number of particles is equal to moles times Avogadro's constant. So if I were to have 2 dozen eggs, I would have 24 eggs. Avogadro's constant is 6 times 10 to the 23, and it's this number because that's how many particles you would need to make up to a substance of its mass in grams. So if you look on the periodic table, carbon's mass number is 12, the atomic number is 6. The atomic number tells you how many protons you have, and therefore attracts the same number of electrons if it was an atom. The mass number, the largest number, tells you the mass of that element, and taking the mass number minus the proton number, that will give you the number of neutrons. So neutrons have a mass of 1, protons have a mass of 1, and so for carbon, its mass is 12. But to have 12 grams of carbon, you would need this amount of the element in order to, as particles, make up to 12 grams. So because it's such a large number, it's not really user-friendly, we tend to work in moles. Like if you, again, were saying if you had 3 dozen eggs. It just makes the number a bit more user-friendly. So if you were to use it, then this is how you would use it. If you had 1 mole, then it would be 6 times 10 to the 23 number of particles. If you had 2 moles, there'd be 2 lots of that. Likewise, if you had 2 dozen eggs, it'll be 2 times 12. So that's an even bigger number. That's huge. So the level of maths that you need to be able to do will be something like this. To use this Avogadro's number, well, you don't always tend to use it, but to use it in terms of moles, then the level of maths that you will need to be able to do will be something like this. 2 people weigh 60 kilograms each. What is the total mass? 120. You think that was easy. The total mass is 210 kilograms. If each person weighed 70 kilograms each, how many people are there? Should we say 3 people? The total mass is 240 kilograms, and there are 3 people who weigh the same. How much do they weigh each? So the relationship we have here, generally, if you were to forget that a mole is a big number of particles, you're able to do the calculation because if you had, say, 2 people at 60 kilograms each, then that's the equivalent of saying 2 people multiplied by 60 to give you the 120. If the total mass is 210, and if each person weighed 70 kilograms each, how many people are there? Then you took this as being 210, and the MR technically being 70. That will give you 3 people. So the level of mass generally is not actually that difficult. Calculate the number of moles in the following substances. If you had 20 grams of ammonia, which is NH3, then we would need to do mass over MR is moles. To work out the MR, you will need to add up using the mass numbers on the periodic table with the number of elements that we have. And the amount that we have in ammonia would be 1 nitrogen and hydrogen, where we have 3 of them, so the ratio is 1 to 3. So we'd have to add that up, so nitrogen being 14, hydrogen being 1 each, gives a total of 17. So the mass being 20, 20 divided by 17 gives you 1.18 moles. We need to work in grams, so if you had a question saying kilograms, you'd need to do a unit conversion. So 320 kilograms would be 320,000 grams. Mass over mR is moles, so 23 for sodium, chlorine being 35.5, don't round it, don't take it to 36. Chlorine is 35.5, giving a total of 58.5. So 320,000 divided by 58.5 gives you 5,470 moles. 32 milligrams is the same as saying 0.032 grams. Mass over mR is moles. So 0.032 divided by 44 is 7.24 times 10 to the minus 4, or 0.000727 moles. A ton would be, in the ton that we will be using, 1,000,000 grams. So if you had 12 tons, that's the same as saying 12 million grams. Divide that by 32, because 2 lots of 16 for oxygen, being molecular. 12 million divided by 32 is 375,000 moles. That's a lot. Calculate the mass in grams in 3 moles of hydrogen. Each hydrogen is worth 1. There are 2 of them. The little number, remember, means that you multiply the element before it by 2. So 3 times 2 is 6 grams. And the last one, sometimes brackets will confuse students. It's easier to add up all of what is in between the brackets and then multiply by how many you've got of them. So MgOH2 means you've got 1 magnesium. It's in group 2 on the periodic table, which means as an ion, it would be a +2 charge. Each hydroxide is worth -1, and therefore that's why the formula is MgOH2, because those charges will cancel out the magnesium +2. Remember, this is ionic, so that means we have a giant ionic lattice in a 3-dimensional structure, but the ratio is just 1 to 2. You don't just have 1 magnesium, you have loads of them, but in the ratio of 1 to 2. So to add up the MR, we'll call it an MR, even though it's not molecular. The magnesium is 24, the oxygen is 16, and hydrogen is 1. So in the brackets, it's 17. And as I said, it's easier to multiply what's in the brackets. So in this case, 2 lots of 17 plus the 24 will give you a total of 74. So 20 times 74 is 1,560 grams. Where you might need to use this in an exam question for Avogadro's number as well might be something like this. So determine the number of atoms present in 0.24 grams of copper. So by combining those both equations, we need to do the mass over mR equals moles first. I say mR, but technically if we are referring to only one particular element, we should say relative atomic mass, and you might see AR, but just for ease, most people will just simply say mR. So 0.24 grams divided by 63.5 gives us 3.78 times 10 to the minus 3 moles. We have 3.78 times 10 to the minus 3 moles. We haven't got 1. If we did have 1, we would have 6 times 10 to the 23 particles. So as we have 3.78 times 10 to the minus 3 multiplied by Avogadro's constant, will give us a total of 2.27 times 10 to the 21 moles. And that's it. If you'd like to see more, please subscribe and message in the comments. Thank you.